Hello and welcome to this video performing 3GPP Release 17 signal analysis with Keysight's PathWave vector signal analysis software, also known as the 89600 VSA. The 89600 VSA software continues to extend the functionality of its 5GNR measurement application with each release of the 3GPP standard. Some of the key Release 17 features supported by the VSA software include NR spectrum expansion up to 71 GHz, also known as FR2-2. This is a very important enhancement to 5GNR as it allows for more spectrum, including the 60 GHz unlicensed band to be used for 5G deployments. For the FR2-2, 3GPP introduces 3 new channel bandwidth of up to 2 GHz and new subcarrier spacings of 480 kHz and 960 kHz to support the wide bandwidth. You will see this during my demo shortly. For FR1, enhancements include new channel bandwidth of 35 and 45 MHz for both uplink and downlink, 1024 QAM modulation for downlink transmission. Release 17 introduces a non-terrestrial network, or NTN, to enable 5GNR-based satellite access. One of the main challenges is a Doppler shift. The 89600 VSA has introduced an extended frequency lock range to be able to synchronize and demodulate to an NTN signals with Doppler shift. 3GPP Release 17 also introduced a new tier of reduced capability, or RedCap, devices to support IoT use cases such as wireless sensors, video surveillance, and wearables. The 89600 VSA existing 5GNR application can be used to test RedCap devices. It is important to point out Release 17 support does not require a new VSA option. The existing 5GNR measurement application with an active subscription covers Release 15, Release 16, and now Release 17 specifications. Let's now move to the demo, starting with a downlink 2 GHz wide signal at 60 GHz center frequency. For a 2 GHz bandwidth, only the 960 kHz subcarrier spacing is available. If this was an 800 MHz or 1.6 GHz signal, you would see both 480 and 960 kHz subcarrier spacings. I'm using a test model 3.1a. You can see a successful demodulation of a 2 GHz wide signal. I am measuring an ideal signal, so the EVM is very low. You can see the constellation diagram of the different channels and signals that are transmitted in this test model. And the frame summary gives you a list of those channels and signals, along with EVM, SNR, modulation format, plus more. The 3D traces are very powerful as it shows EVM and power per symbol and per subcarrier. The 3D power is very useful when verifying base station systems, for example, to make sure the power per each resource element is balanced. You can use markers to read the power and channel information. You can also couple the markers with other traces to help you understand the identity and characteristic of a symbol simultaneously in a time and frequency domains. If the transmitted signal has channel coding, as in this case, you can decode the signal and get CRC information. Let me move on to an FR1 demo. As I mentioned, 35 and 45 MHz bandwidth are newly added to Release 17. For this demo, however, I'm going to use 100 MHz bandwidth to show the 1024 QAM signal. Test models 2B and 3.1b are newly added for 1024 QAM modulation. This is a much denser constellation than the 256 QAM in previous releases of 3GPP. You see similar set of measurements as in the previous demo. When dealing with signals with low SNR or system impairments, detecting the ideal constellation points for an accurate EVM measurement will become a challenge, in particular when dealing with a high-order modulation format, as in this example. On the VSA, IQ reference values for all zeros or for PN23 as defined by the test models can be used for PDSCH EVM calculation. This avoids the problem obtaining the ideal constellation points for an accurate EVM results. When using IQ references, bit error rate results are shown in the slot summary table. In summary, the 89600 VSA software provides support to 3GPP Release 17 features using its existing 5GNR measurement application. In design, it is used with Keysight simulation software such as System View. In test, it is used with more than 400 hardware model numbers as well as other measurement front-ends used to provide IQ data to the VSA. For example, recording using different file formats. To learn more and download a free trial, visit us at these websites.